Welcome to ISL enabled virtual lab of CSIR.
Water is invaluable. Life began because of presence of water. It is essential for life. At the same time, we are aware that it is constantly getting polluted by dangerous chemical and biological waste. Drinking contaminated water can cause serious health hazards and waterborne diseases. One question that occurs to everyone's mind: am I drinking safe water? Well, to answer this question, let's go to Quality Control and Quality Assurance Division, an ISLEVL accredited lab of CSIR, Indian Institute of Integrative Medicine. We have now entered water testing laboratory of the institute. All the parameters will be done as per BIS Indian Standard 105002012. We are going to do pH, turbidity and calcium using the calibrated equipments with volumetric analysis. Now let's start with pH. These are some of the samples. Let's take one. We are going to see the pH of this sample. For pH, we are going to use the pH meter. This is the calibrated pH meter. This is the electrode which is going to tell the pH. So water is being poured and we are going to measure the pH. So we are going to take 50 ml of water. The electrode is being dipped into the sample which is being tested. Here is the pH. The pH is 6.69. Going to the next parameter, we are now going to see turbidity. This is turbidity meter. These are some of our secondary standards. Here is the sample tube. We are going to fill our sample in the sample tube. The sample will be poured into the test tube up to the mark, and this is the sample holder. The sample is being put into the sample holder, and here comes the reading, and the reading is 1.2 NTU. Well, within the range. The range is from 1 to 5 NTU. Moving on to next, we are going to see calcium using volumetric analysis. So this is our burette, our calibrated burette, and this is our secondary standard, 0.01 molar EDTA, ethylene diamine tetraacetic acid. So this is going to be filled in the burette. Here we have to make sure that we have to read the lower meniscus. So the lower meniscus reading is 0.4. The sample is being poured into the calibrated measuring cylinder. We are going to pour 50 ml into the volumetric flask. Then the indicator of pH 12, 1 ml. Going to add Calcon indicator. So the color will change from pink to blue. We are doing the titration. Has to closely observe the end point. See, we have achieved the end point. The color changes from pink to blue. Using the calculations, we can find out calcium. Have you seen the distillation unit? Let's see. This is the distillation unit. We are going to distill water. Here is the tap water. This is the condenser. The water evaporates. You can see the vapor which is going in the condenser. This is the inlet by which the water is being cooled. This is the outlet. The pure water is being collected in the RB. We are going to test heavy metals, a very important parameters, using a sophisticated instrument, inductively coupled plasma mass spectrometer. Here is the sample preparation. This is the sample to be tested. We are going to measure it in the Tarsen tube. The water is going to be there. 50 ml of water will be taken. Adding internal standard to the sample. We are going to put the sample in the auto sampler. This is the ICPMS, inductively coupled plasma mass spectrometer. This is the spray chamber. Here the plasma is going to be generated at the temperature of 10,000 degrees centigrade, and this is the mass. The sample is being taken through the auto sampler. The sample is coming through this pipe, through the peristaltic pump, going to nebulizer for aerosol formation. The larger droplets are going into the drain, and the finer smaller droplets are coming inside. The torch is being in contact with plasma where the sample are being heated. Thereafter, it is coming into a vacuum with the mass analyzer and converted into ions. And we are seeing the elements arsenic, lead, cadmium and mercury, are very toxic heavy metals, unsafe for drinking. Water should be free from these heavy metals.